Back. Now we want to learn about the arc cosine function. First, recall the definition of the function, graph of the function fx equals cosine x. At 0, cosine x has value 1 and then it comes down. At pi by 2, cosine has value 0. At pi, cosine has value -1 and then climbs up. So this is again an oscillating function. It's a periodic function. All right. Now, this function is again not one-to-one. You see, here is an horizontal line which meets my function, my graph several times. In fact, it will meet the graph infinitely many times. So the function, cosine function, is not one-to-one. So we have to restrict the domain from 0 to pi. If I restrict the domain, this is the curve of cosine x. On 0 to pi, range is -1 to 1. And here notice how it is 1 to 1. Every horizontal line will meet it exactly once. So now we can define the inverse of cosine function. F inverse x is y if and only if fy is x. So you define the inverse cosine function, or also called arc cosine function. Cosine inverse of x is y if and only if cosine y is x. So notice cosine here is a restricted domain. So my y goes from 0 to pi. Okay. Now cosine is from 0 pi domain to the range -1, 1. Cosine has this domain 0 pi and its range is -1, 1. Therefore, the inverse has domain -1, 1 and a range 0 pi. Okay. So, cosine inverse of cosine x is x when x is in the domain of cosine. Domain of cosine right now is 0 to pi. Likewise, cosine of cosine inverse x is x. Cosine inverse domain is -1 to 1. So this x now is between -1 and 1. So here is the graph of arc cosine. It should be cosine, not sine. So this is cosine. I need to take the diagonal line y equals x and take its reflection with respect to the line y equals x. So there you go. That's your curve y equals arc cosine x from -1, 1. That's your domain and range is 0 to pi. Okay. So derivative of the arc cosine function. Let y equals cosine inverse x. That is cosine y is x. So here y is between 0 to pi, you see, and x is -1 to 1. All right. Now we are going to take derivative of this equation, both sides, with respect to x. Derivative with respect to x of cosine y is derivative with respect to x of x. Derivative of cosine is negative sine of y, and by chain rule multiply dy dx. Now y is cosine inverse x, so we want dy dx. In other words, dy dx is 1 over negative sine y. So negative 1 by sine y. Now use the fact that sine squared y plus cosine squared y is 1. So sine y is plus minus square root of 1 minus cosine squared. Now you see, between 0 and pi, sine is positive, non-negative rather, between 0 and pi. So recall y is between 0 and pi. Between 0 and pi, sine value is non-negative. So in other words, I don't take the negative root, I simply take the positive root. Sine y is positive square root 1 minus cosine squared. Therefore, derivative of cosine inverse, which is y, derivative of cosine inverse x with respect to x is negative 1 by sine y. Sine y itself is square root 1 minus cosine squared y. Cosine y is x. So derivative of cosine inverse is negative 1 over square root 1 minus x squared. And this is valid for x between negative 1 and 1. Again, technically, you should have less than in both these conditions. But I'm allowing equal in case you are interested in one-sided derivatives. All right. So the formula for derivative of cosine inverse is negative 1 by square root 1 minus x squared. All right. So the next topic will be on arc tangent. Okay. So we'll continue in our next video.